Welcome to Bagana Valley, which is where I live. And I'm absolutely delighted. A friend has just sent me a very nice present. And I think there's a lot of physics in this present. And it's a lovely prayer wheel. Now, you'll have seen a lot of these around. People have them in their motor cars. And where's the physics in this? Well, if I come a little bit nearer, you can see that this is a prayer wheel which works with the sun. The radiant energy from the sun shines on this little solar cell here. The solar cell converts the sun's radiant energy into electricity, and this turns the sun's radiant energy into electrical energy, which feeds into a little electric motor inside. The electric motor then turns the prayer wheel. So we have the radiant energy from the sun being converted into electrical energy, and the electrical energy being converted into kinetic energy of rotation of the prayer wheel. And the prayer wheel rotates. So that's a wonderful example of two energy conversions in this very nice present that I've been given. So I'm going to go in and have my cup of coffee. So, Judy, I'm going to make you a cup of coffee. And to do that, I need to boil some water. And so I've got here an energy converter. This energy converter is an electric kettle. And I'm feeding in electrical energy, which turns into heat energy, which heats the water. But when the water boils, what do I see? The water rises up into the air like a cloud. And if you've ever tried doing this in a cold kitchen, you'll see that it makes your windows go frosted because the water vapor condenses on the cold window. Now, what does this remind us of? It reminds us of the water cycle, because the hot water evaporates, goes up into the sky, turns into clouds, and then when the clouds become cold, the water falls down as rain. So this is just like the water cycle. Let's look just for a reminder at the water cycle, because you've all learned about that in school and you've drawn pictures of it. So let's go and look just for a moment about the energy changes in the water cycle. And of course, to make the water cycle, we don't plug the earth into an electrical power supply. What's the equivalent of the electrical energy in the water cycle? It's the radiant energy from the sun. The radiant energy from the sun made the prayer wheel turn with kinetic energy. The radiant energy from the sun evaporates the water, causing clouds which then fall as rain. So, the water cycle. We'll have a little look at it. So, here we've got the real water cycle. Not a picture, not a diagram, but here all around us we've got the water cycle in action. First of all, we can just see the sun giving us heat energy, radiant energy. And down here we've got a river. And if you think of a little molecule in the river down there, it flows down the river all the way into the Bay of Bengal. And the sun's energy causes the water in the Bay of Bengal to evaporate. So our little molecule, which has made the journey all the way down to India, gets energy to rise up into the sky, and we see it as clouds. And then the clouds cause rain, and the water vapor comes down as rain, feeds into the river, and then back on the journey to the Bay of Bengal, up into the sky, round and round. Radiant energy from the sun causes the water vapor to rise, so we get gravitational potential energy, which brings the water vapor up into the clouds and then back down again. So when you see a diagram of the water cycle in your textbook, think about it in real life. It's all around us. So let's just look a little more at the water cycle, which I've brought on my computer. So I've brought up on my computer an animated diagram of the water cycle. Now, this is a picture you'll be very familiar with from your school textbooks and from drawings you might have made in your own notebooks. But let me remind you how useful a computer can be. You can get such a lot of information from a computer and from the internet. I've brought up this picture, a very quick search on Google for water cycle, and I get this animated picture. Remember, often with a computer and the internet, you can bring up pictures which are much better than the pictures in your textbook because you can get animated pictures. Now, here's the water cycle. And you'll remember the sun's rays warm up the water in the sea and on the land. They cause the water to evaporate and to rise up into the sky, and they form clouds. The clouds then cause rain to fall on the mountains, and the water runs down rivers back into the sea again, round and round and round. But we're familiar with the water cycle, but let's just think about the energy conversions that are going on in the water cycle. The sun, you'll remember, a giant nuclear bomb, causes rays of infrared radiation to come down to the earth, and the sun's nuclear energy is converted into radiant energy, and the radiant energy is then converted into heat on the ground and in the sea, and the heat energy then causes the water vapor to rise up. So the heat energy is giving gravitational potential energy to the water. So the water rises up here. It's got lots of gravitational potential energy. What happens then? The gravitational potential energy is then turned into kinetic energy as the rain falls, but it falls high up in the mountains here in Bhutan, so it's still got a lot of gravitational potential energy when it's in a river up at the top of the mountain. And that gravitational potential energy is turned into kinetic energy as the water runs down the river. And we can use the gravitational potential energy of the water high up. We can use it to create electricity, hydropower. So all our hydropower in Bhutan depends on the water cycle, and the hydropower that we get comes in the beginning from the sun's energy, the radiant energy, coming down to the ground and creating heat energy. So we depend on the water cycle for our hydropower that is so important to the future economy of Bhutan. Now, hydropower is not new in Bhutan because we're going to look at a way in which the gravitational potential energy of the water in the river has been used here in Bhutan for hundreds of years with a particular application, a particular energy conversion, which we see in a water-driven prayer wheel. So let's go and look at a water-driven prayer wheel. So here we've come to look at a very, very old technology which has existed in Bhutan for hundreds of years, and it's the water-driven prayer wheel. Here you see water running down and turning a prayer wheel. Where did this water come from? Well, it came from rain, from the clouds. So we're back to our water cycle again. The water comes down, it's got gravitational potential energy. That's what's making it run down. And it comes along and it turns the prayer wheel here. So remember, this technology, energy conversion, gravitational potential energy into kinetic energy of the water, and then kinetic energy of the prayer wheel, this has existed in Bhutan hundreds of years. So how does the water turn the prayer wheel? Well, it turns the prayer wheel using a turbine, a very old style turbine. And the water hits the paddles of the turbine, causing rotation. The prayer wheel's connected to the paddles, and so the prayer wheel rotates. Now, this is exactly the same principle as all the hydroelectric power stations in Bhutan use. Falling water hitting a turbine, causing rotation. But in a hydroelectric power station, instead of the rotation causing a prayer wheel to go around, we have an electrical generator. And the water causes the generator to turn, which produces electricity.
The Chukha hydropower plant is the oldest mega power project in Bhutan. The project was fully commissioned in 1988 with an installed capacity of 336 megawatts, with the assistance of the Government of India. It is a run-of-the-river power project with a reservoir capacity of about 1 million cubic meters of water of the Wanchu River. The water is diverted from the diversion reservoir into the power plant built inside a beautiful hillock. The gross head, which in simple term is the elevation difference between the water level at the diversion reservoir and the turbine at the powerhouse, is about 468 meter, and the net head is 435 meter. The dam, with the highest operating level at 1,842 meters, is a structure built over the Wanchu River to divert the water into the power plant. During the lean season, from October to May, in order to supplement water into the Wangchu, Tishalomchu, a tributary is also diverted into the dam. To prevent damages to the dam, a spillway is used to release the water when the inflow is more than what is required for full generation. The water from the diversion reservoir is diverted into the tunnel through two intakes. In order to prevent debris entering into the power plant, a screen-type mechanism called trash rack cleaning machine is used in front of the intakes. The intake is the beginning of the water conductor system. A few hundred meters after the intake structures, there are two desilting chambers. The function of the desilting chambers is to let all silt particles of size over 0.2 mm to settle down under gravity, so that the water is free from silt contents. This arrangement is required for minimizing wear and tear on the underwater parts and equipments like runners, nozzle spears, and nozzle tips. The particles that settle down are flushed through the silt flushing tunnel. In summer, when the inflow is more than 120 cubic meters per second, the silt flushing gate is continuously kept open. The water from the desilting chambers further flow through a 6.5 kilometer long tunnel called Head Race Tunnel. At the end of the Head Race Tunnel, a structure called surge tank is connected to the water conductor system. The local stream, Lubichu, is also diverted to the surge tank to enhance generation during lean season. From the surge tank, two steel-lined pressure shafts originate. A butterfly valve is installed on each pressure shaft. The valves are used to primarily stop the water flowing into the pressure shaft during the maintenance of turbine and its auxiliaries. It is also emergency tripping. These pressure shafts are inclined at an angle of 50 degrees. The ends of two pressure shafts bifurcate into 4 penstocks for carrying water to the generating unit. The main powerhouse is located inside the tunnel. It houses 4 turbines, 4 generators, transformers and other auxiliaries at different floor levels. The 4 penstocks feed the 4 Pelton turbines with the water under high pressure. The force carried by the water spins the Pelton turbine at a rated speed of 300 revolutions per minute. After spinning the turbines and transmitting practically all its energy, the water is discharged into the tail race tunnel, and through the tail race tunnel, the water is again released into the Wangchu River. The Pelton turbine and rotor are coupled by a shaft. The rotor is being rotated by the turbine. Electricity generation is taking place at the generator chamber. From the generator terminal, 3-phase power is connected to the transformers. The function of a transformer is to change the voltage level, that is, to reduce or increase it, suitable for transmission over long distance or utilizing to safe level. From the switchyard, after meeting the domestic demand of Bhutan through dedicated transmission lines, power is exported to India. In order to tap the remaining potential of the Wangchu River, the Tala hydropower plant diversion reservoir is located downstream. This diversion reservoir is used to generate another 1020 megawatt of electricity.
So when you think of hydropower in Bhutan, there's nothing new about it. It's existed for hundreds and hundreds of years. And on this arrangement of prayer wheels, you'll see that very cleverly there are 4 water-driven prayer wheels, all using the same stream of water. And that's exactly what one can do in Bhutan. If you think of Chukha hydropower station and Tala hydropower station, they all work off the same river. Chukha is higher up, Tala is lower down. They use the same water. And Bhutan's so fortunate. The rivers come from such a high altitude that you can fit 2 or even 3 hydropower stations on the same river flow, using the gravitational potential energy of the water high up to turn into kinetic energy to rotate turbines which generate the electricity that we're so fortunate to have in Bhutan. So hydropower, a wonderful example of energy conversion. Remember, it's not new. These have existed for hundreds of years. So this program has been all about energy conversion, converting energy from one type of energy to another type of energy. And as you can see, converting energy is all around us. Now, you're in class 5 and you'll be learning all about energy. And I want you to remember that energy conversion is everywhere. And whenever you see anything working, I want you to think about the sort of energy that's coming in and the sort of energy that's coming out. Whether it's my mobile phone, where chemical energy in the battery is now being converted into sound energy. Whether it's water-driven prayer wheels which have existed in Bhutan for hundreds of years. Hydropower, which is exactly the same principle as the water-driven prayer wheel. Whether it's a torch where you take the chemical energy in the battery and it's converted into electrical energy and then into light energy and heat energy in the bulb. Whether it's a motor car where the chemical energy in the petrol is converted into kinetic energy of the vehicle. So conversion of energy is all around us. And when you study all about energy and energy conversion in school, I don't want you just to look in your textbook. I don't want you just to write lots and lots of notes. I want you to think about it as you're walking around this beautiful country that you live in. Energy conversion is everywhere, and it's the basis of our whole existence, and it's the basis of the existence of the world. And remember, where does all our energy come from? It comes from up there. It comes from the sun. So enjoy thinking about converting energy from one sort to another, and we'll look forward in our next program to looking at some more physics all around us. And remember what we say at the end, physics is fun. Why? Because physics isn't just in a textbook or in a school classroom. Physics lives around us all the time. Now, if you do have questions, at the end there is a place where you can send your questions to. And we'll gather in a whole lot of questions, and in one program later on, I'll try to answer some of your questions. So do send in questions about the topics we cover. Good luck in your studying of physics.